Hey guys, let's check out this conservation of energy example. Here we have three objects of equal mass and equal radius, but they have different shapes. Remember, your shape is what determines what equation your moment of inertia has. And it's usually something like a fraction mr squared. But the number in here depends on the shape. So if you have different shapes, you're going to have different I equations. They're all released from rest at the same time from the top of an inclined plane. So I'm going to have, here's a solid cylinder. Here is a hollow cylinder. And here is a solid sphere. They're all from rest. They all have the same mass, right? So they have the same mass, the same radius. They all start from rest. And they all start from the top of the inclined plane. They're going to start from the same height as well. Everything is the same except the shapes. And I want to know who reaches the bottom first if they're released at the same time. And this question will depend on your moment of inertia. What I want to remind you is that moment of inertia is a measurement of angular resistance, of rotational resistance. So you can think that the greater my I, the heavier I am, the more I resist rotation. Therefore, I will get to the bottom last because I'm slower. Okay? So more I, you can think of this as being heavier. Now, it doesn't mean that I have more mass, right? That's why I have heavier. I have more resistance. Therefore, I am slower. Okay? Now, a solid cylinder has a moment of inertia of half mr squared. A hollow cylinder has a moment of inertia of mr squared. So you can think that there's a 1 in the front. And a solid sphere has a moment of inertia of 2/5 mr squared. So in this question, all we're doing is comparing these numbers because the m and the r are the same. Now this is a little bit easier if you use decimals. So this is 0.5, this is 1.0, and 2/5 is 0.4. Okay, and you can see from here that this one is the lightest one. Okay, because the coefficient number in front of the mr is the lowest. It's the lightest one, therefore it is the fastest one. Therefore, it gets to the bottom first. Okay, it gets to the bottom first. So the sequence is that the solid sphere is first. I'm going to write it like this. Gets to the bottom first. The second one is going to be the solid cylinder is second, and the third one is going to be the hollow cylinder. Okay? Now, there is a pattern here. There's a reason why the hollow cylinder is slower than the solid cylinder. Solid cylinder has very good mass distribution. The mass is very evenly distributed. And remember, the more evenly distributed the mass, the lighter you are, the less I. So better mass distribution means lower I, which means you are lighter. Okay? A hollow cylinder has all of its mass concentrated on the edge. It has worse mass distribution, which means it has a higher I, which means it is heavier. So it has a worse mass distribution, therefore it is heavier. Now, a solid sphere is even more well distributed than a solid disk. A solid disk has all the mass on a thin layer like this. A sphere has basically the most perfect mass distribution you can have. That's why it has the most symmetrical one. That's why it has the lowest of them all. So the sphere is always fastest. Okay? So that's it for this one. Let's keep going.